Hello, good morning. Today we are going to take a gas, collect it in a tube, and we can either find several things about this gas. I'm going to subtract the mass before and after to find the mass of gas released into a tube, and we can either find the density or the molar mass of this gas, and I know it's butane, so we'll talk about the ideal gas law and butane in a moment. Okay, here's the balance. I'm going to take pictures of the mass before and after. So I'm going to find the mass before. We'll take a picture of this. I'm going to practice with this in a moment, but it will not be 80.015 grams, but I can read this to the nearest thousandth of a gram, milligram. We're going to collect this gas by water displacement. So we'll talk about Dalton's law of partial pressures. The gas will go into this tube. I will set up a eudiometer. I will fill it with water. It'll be above this hole here. See the little stick figure? That's where the gas comes out. We'll read the gas pressure with the barometer using Dalton's law of partial pressures and the water vapor pressure. At this temperature, we'll read the volume with the eudiometer, and we can find several things. First of all, find the moles. And my students will video this later this day. Okay, we are going to find the mass of gas released from this canister. Now come over here and we're going to find the mass of this canister, before and after. So the before is 79.967 grams. Ready? Okay, I'm going to go release it. I'm going to find the temperature, pressure, and volume of this gas. So hopefully I'm going to use my little tubing to release the gas inside the tubing. It's going to leak a little bit. That's going to be my major source of error. But let's pretend like it's not. Let's pretend like there's other error too. So hopefully this is not going to have bubble trouble. I lost some bubbles, dang it. There's a couple of bubbles leave. I did not go past 90, did I? Okay, it's going to read over here. It's like 80 something. So I'm going to do a little bit more. No, I'm not going to tempt fate. I think I'm going to stop there. So if this mass is about 0.2 something grams, then I did okay. If it's like 0.3 something grams, I sucked, and it's going to be too much error. So let's find the mass of this. Somebody want to calculate real quick. 79.774. Someone with a calculator subtract those real quick. It's 773 because of the motion of the balance. This is a good balance to the milligram. .193, that should be okay. 0.193 grams. That's how much mass of butane. That's like very small. If I use the other balance, it'd be 0.19. I'm using 0.193 to have more accuracy. Okay, so I'm going to take that off. In a moment, we're going to read the volume, temperature, and pressure, and then do some calculations. Stop. Okay, so right now this is filled with butane, which is more dense than air. So we're going to do a little experiment. Okay, so I'm going to flip it without getting the water everywhere. So right in here is butane, which is more dense. Okay, everybody get close. It's not going to blow up yet. Okay, so this is not going to blow up. So when I pour water in here, it's going to displace the gas, isn't it? Mm-hmm. Can you see it, everybody? Lainey, can you see it?
I think so.
Okay, here we go. I'm going to pour water. Okay, what do you see about the edge?
Little wavy lines.
That's the gas leaving. The different gas has a different density, so it's a different index of refraction. Looks like heat waves. It's not heat waves, it's the index of refraction of a gas. So I just let the butane go out. Okay, I'm going to leave this over here out of the way. Okay. Video, see it?
I think so.
Okay, here we go. I'm going to pour water. Okay, what do you see about the edge?
Little wavy lines.
That's the gas leaving. The different gas has a different density, so it's a different index of refraction. Looks like heat waves. It's not heat waves, it's the index of refraction of a gas. So I just let the butane go out. Okay, now that part of the lab, I didn't want to ignite the butane, so I'm just going to hold that. Would you hold it for me? So I've got to add more gas, and I don't care about the mass or volume. I'm just going to get gas in there, okay? Hold that for a moment again. So we're going to keep that up so it doesn't drain out. Would you grab one of the lights off, see how the closest light off? Other one. Maybe we can see it better. Okay, you can back up now. Are you ready? Okay, so this is a controlled combustion with butane. You've all used butane lighters. This is a butane lighter. Does it blow the crap up? No, I don't think so. So I'm going to do this because it's more dense. It's going to pour out, isn't it? Ready? Ready, Lainey? So I'm pouring it out. And eventually it does complete combustion. There's some water vapor in there. That's about it. Okay, thank you.